So we are moving on to the next concept. So I entreat you to solve a lot of questions on distributive properties. Yes, bring any question, any troubling challenge, and as a class we'll do it together. You can also post your comments, your suggestion, or your challenge onto the group page. Now we move on to the next concept, which is identity or neutral elements. Identity or neutral elements. Now, this is the plus sign. This is the plus sign. Now, if I have 6, I have 6 plus a number, and the answer I need is 6. What number will you put here to give me the answer 6? Think about it. Is 0. With the same as if I have 0 and I add 6, I will still get the answer 6. I hope you remember this concept. Which property is this? Commutative. Commutative property. Now let's take another operation, multiplication sign. Now I have 6 again times a number, and I need the answer to be 6. If we are taking correctly, it means the missing number is 1. We can also say that 1 times 6 is equal to 6. And the same property applies here, commutative. Commutative. Now, for addition, there's this number or element. Anytime you add to any other number, you will get the second number. So for example, there is a number x. If I add it to 6, I will get 6. So x is 0. So for addition, the identity element is 0. Any number you add to 0, or any number, or if you add any number to 0, you get the number itself. So 6 plus 0 is 6. 0 plus 6 is 6. So the identity element for addition is 0. Identity element for addition is 0. Now when we come to multiplication, any number that you multiply by 1, you get the number. Or if you multiply 1 by any number, you still get that same number. So for multiplication, the identity element is 1. Identity element for addition is 0. Identity element for multiplication is 1. Now, for binary operation, we are going to introduce an element which is on its own, and the element we use is E. So anytime you see E in a binary operation, we are referring to the neutral element or the identity element. The identity. So let me state that if an operation is not commutative, that operation cannot have an identity. If an operation is not commutative, we have learned that if A, let's say star E, should give us A, since E is identity element. Anytime you operate on the identity element, you get the other elements. Or E star A is equal to A. So it is only when an operation is commutative that we could have an identity element. So let's check on work example 1.13. Example 1.13, sorry. Example 1.13. Now, we are given an operation upside down triangle. And we are told that it is defined on all real numbers. Please refer to the notes. For all real numbers. As P operation K is equal to P plus K minus PQ. Now, this is the definition for the operation. So, if we are applying the concept of commutative under identity, we first have to prove if this operation is commutative. So, for commutativity, then P operation K must be equal to K operation P to hold. Both sides of the equation must be equal. So let's use the definition to expand. So we have P plus Q minus PQ must be equal to Q plus P minus Q P. So now let's rearrange. Now addition is commutative. So you can bring the P first plus the Q minus multiplication is also commutative. So we can have P Q. So since the left hand side is equal to the right hand side, we say the operation is commutative. So this is only to prove that it's commutative. Now, let's find our identity element. Let's find our identity element. So we are going to we can use any of the element to do it.